What's up, peeps? Thanks for coming in. Thanks for joining in with Tanzu Tuesday. Today we've got Scott Rosenberg. We've got Whitney as well on the call. Super stoked. We're going to be talking a little bit about Tap later.
I'm excited. I love those super chill vibes coming in. That was nice. Super professional.
I figured, we could mix it up a little bit. We've been streaming with StreamYard for those of you joining in on YouTube now. We got the simultaneous stream going, right? Ooh, Tiffany popping in here as well. What's up, Tiffany?
I have to restart my computer and now it's connecting to the internet. Yay!
Yeah, so the whole crew here on Tanzu Tuesdays today, and we got Scott coming back. Double stream, double the Scott. All right.
Exactly. Should be fun.
But yeah, it's where's everyone coming in from today? I'm sure we have some people joining in from the chat. I see some people here on Twitch. We got Cora coming in, saying hello, as well as A Fuel coming in from Las Vegas. What's up? I'm here.
Hey Art. Hey Cora.
In Breckenridge today. Yeah.
Spencer's here. Hi, Spencer.
What's up? Thanks everyone for coming in. Yeah.
Cora says the more Scott, the better, which I agree with. I second that. Yeah.
Yeah, that's a +1 on that for sure.
That's pretty cool.
By the way, everyone mentions, we talked on the last stream about the fact that I don't sleep. Apparently Cora doesn't either, because I was chatting with her at 2:30 in the morning, her time on TCE on Slack. So exactly.
Hello, Keith. Good to see you.
So, Scott, I understand that you're bringing us a pretty nerdy presentation today. In true Rosenberg spirit, you bring in some more of your cool hacks in.
Yeah, I think Tap is built for hacking, so might as well.
Yeah, no, it's really cool. I think we always try to bring the spirit of real stuff happening right on Tanzu Tuesdays, and so we're not just talking theory. This is practitioners in the Tanzu community coming in to watch other real practitioners doing real stuff, and I'm always excited. But, what's everyone doing this weekend though? Before we jump in,
goodness.
Upcoming weekend or past weekend?
I guess the upcoming weekend
feels so far away.
I guess so. Maybe. All right. So what did we do last weekend? And I follow Whitney on Instagram. Actually, I saw that she was projecting a route on the bouldering wall.
Yeah, I've been working on this route for a long time, and it's been maybe 7 or 8 tries. But I've been doing it for this time last year. I couldn't even do a pull up, and now this one route has me climbing on the ceiling, and it makes me feel pretty cool.
Yes, pull-ups. Pull-ups are such a hard exercise.
I feel like Spider-Woman, yeah. And I feel
do you ever cosplay at the gym?
On Halloween there were some people in costumes at the gym.
I've never been to the climbing gym at Halloween.
Yeah.
Time.
But at 42, I feel like I'm the strongest I've ever been in my life, and so I dig that. It's never too late.
I've started sending pull-up videos back and forth with me and my buddy. I was just doing day 2 yesterday, and they had a pull-up bar over at the gym here, and yeah, it's so hard. Since going to the gym, I put in 20 pounds, and it's every additional pound on your body just makes it so much harder to do that exercise.
But that's more weight that you're lifting, so you're getting stronger, right? Maybe?
Exactly, right? Yeah, I don't even need to wear a weight vest to just keep getting stronger, and then there you go, right?
So are y'all challenging each other or encouraging each other? And also, how many pull-ups are you starting with, and are you adding them at a certain rate?
It's a mutual benefit.
Yeah.
For anyone tuning in for the first time, that would be Whitney's brother's music group, right?
Yep, and that's the band
Mutual Benefit.
I played in Mutual Benefit for a year.
Yeah, you can go listen to Mutual Benefit on Spotify, or YouTube Music and wherever. Yeah, it's we're doing. I've been sending him 10, and he just sent me 15 yesterday. So I mean, I guess he's upping the ante. You know.
Nice. I got.
I will start with 0.25 pull-ups. I like it. That's
That's
actually the hardest
That's
part.
0.25 more than me.
It's good that we can quantify things. Yeah.
In gymnastics, we had to do pull-ups. I just couldn't, so they kept like grabbing me, like lifting me up because I couldn't do it myself.
Yeah. That's exactly what I was doing last year. I had someone like pulling me, like holding the bottom of my weight to see how much I could put in my arms. It wasn't very much. Yeah.
Yeah, they have those assisted machines where you can just like set it to like 70 pounds of like assistance and it'll like lift you.
Oh, yeah.
Or when I was training muscle ups 2 years ago, which is like a pull-up variation where you get over the bar, I was using resistance bands before I could do them unassisted.
But-
And so you just hang the band on the bar and you like put your feet in it, you know?
Cool. What the thing about like when is it in modern world, when is a time you would ever need those muscles? Like unless you're fabricating a rock climbing gym experience or like whatever. So I completely identify with the fact that most people don't know how to do any push-ups because why would like pull-ups? Like why would they? What is it?
Yeah. This is
Like-
actually this is a really fun question because training in parkour, if you ever need to get up on top of something, there is a range of motion called a climb up. And it's basically you get up on like a wall or, you know, like something that's taller than you, or it doesn't even necessarily need to be. And just that top out motion, like if you're at the top of the climbing wall. So that's sort of like a pull up motion, but there's other things going on. Like you use your feet to grip the wall and push up. But yeah, I don't know. That's the only thing I can think of. Otherwise, it's like being completely suspended off of a ledge. You know,
we need to like stand on more tables, just like climb up on our kitchen counters, just so we can have practice using our arms the way we would have an evolution.
It's like being a kid all over again.
Yeah. Maybe when you go to the playground and you're playing groundies or some other playground game with people, then pull-ups matter. You know. So
yeah. If you want to get into tree climbing again, yeah.
Oh, we got Findal joining us saying, I'm not going to get anything done today. We got stream after stream on the Tanzu channel.
I tuned in stream recently. Findal was working out. He has a NoDocs plugin for VS, not Visual Studio Code, just Visual Code. The one that's for Windows. I was learning about that.
Oh, Visual Studio.
Visual Studio. There it is. 2 out of the 3
the
words.
One that you pay for.
Picked the wrong 2. Yeah. So he's working on a no-doxing plugin, so your credentials just automatically get hidden if you're streaming. It's super cool.
Interesting.
Yeah.
Yeah, that would be, I would like to see that actually. I'm always worried, you know, when I'm sharing my screen and that kind of thing. Like, you got to turn off your notifications. You know, you hope your mom doesn't text you. You know? Can you get something from the store? Yeah.
I got a brand new iPad and I have everything silenced, but I didn't turn off some settings. So whenever everything's silent all the time, but then it just was a sneak attack. I got a phone call and that thing was so loud in my space. And thankfully that didn't happen during the stream.
Yeah, maybe the hack is to have a streaming device that doesn't have any of your social or like any of your work stuff logged in, and you just only are using that for streaming. Then you never have to worry about it.
Yeah.
You like separate it physically instead of digitally with a window manager or whatever. So yeah. Cool. Well, Scott, you said that you had some slides for us today, right?
Yeah.
What are we going to be talking about?
For the first time ever. We're going to be talking about
ever.
You know, there was a first time for everything. But no, today we're going to talk about Tanzu Application Platform, which is a new awesome product from VMware.
Can I introduce you?
Yeah.
Interrupt you, please, because I want you to introduce yourself. So the word introduce snuck into my. Will you introduce yourself? Tell us who you are, where you're from.
Yeah, for sure.
What you do.
Yeah, so I'm Scott Rosenberg. I'm based in Israel, and I work for TerraSky. We're a global systems integration company that are partners with VMware, AWS, Google, many other vendors, and I'm the practice leader for cloud technologies and automation at TerraSky, leading the Tanzu portfolio. So yeah, that's
amazing.
a bit about me.
And what I love about you, Scott, is your endless curiosity. You're inspiring and really fun to watch and learn from. So I'm so glad to hear it. Yeah.
Thank you. No, it's an amazing time to be in tech and I love how interesting things are and how much there is to learn. And in today's world where there is such a community being built around tech, especially in the Kubernetes world, it's really fun to be a part of this community.
Yeah, absolutely. The community portion of cloud native technologies is just, it's a total gift to be a part of. I'm really happy to be here with all of you. Mm-hmm.
Yeah, no, for sure. So let me bring up my slides, I think. Figure out 1 second. And let me share that screen. Awesome. And let's see.
Lee, do you have plans this weekend? Oh,
there we go. Awesome.
Probably more.
So that'll be still more than me, no matter what. So yeah, and if we're talking about Tanzu Application Platform, really the way that I look at it is that it's the next gen platform as a service, right? We've had platform as a service before, whether it's, you know, Pivotal and VMware's PCF or now TAS, or things like OpenShift or Heroku or different things out there. But this is really the next generation of that. And it's really interesting where this comes from. And if we look at kind of what the idea of it is that, you know, Kubernetes, which we all love, is a very steep learning curve. Just to bring up an application on Kubernetes, we have huge amounts of YAML that we actually need to write. Everything is declarative, so that's great, but we need to configure our deployments and our routing and our services, and how do we set up scaling, and how do we set up eventing, and how do we make sure that this is actually portable, and how do we make sure it's a microservice and not a monoservice. Just take a monolithic and put it into a service and yay, we're in microservices. No. So how do we really deal with all of this? And this is not an easy task for many. And trying to do this shift left idea where we're trying to make our developers really enhance our developers' work streams and make them more productive, it's very difficult when we give them raw Kubernetes. And also giving them raw Kubernetes is just really dangerous. What you can do with Kubernetes is really dangerous. It's like giving someone admin to the AWS console. Enjoy your bill at the end of the month. So it's really, it can be dangerous, and it's hard. And really, if we look at the market, I know overall, just in terms of platforms and all that, most organizations have realized that have been in Kubernetes, they build an internal platform because you can't just expose it. And when this is the case, that we see that we're building all these internal platforms, we see that we're, you know, most organizations that have one platform actually have two, because they built one and 96% of those organizations built another one because the first one didn't suffice. So that's really the issue that we have when we go with do it yourself. Kubernetes, managing these things are very difficult. And on the other hand, the platform as a service approach was typically that one size fits all. It went down the approach of, great, we'll do a CF push, we'll do whatever it is, and, you know, one size fits all. The pipeline of from my source code to the deployed app with a URL, there's one path. And that doesn't work in today's world with our eclectic types of applications running on Kubernetes, with persistent applications and distributed applications and, you know, just web applications. Everything has its own uniqueness, and those things need to be dealt with. So this real idea of a path to production that's one size fits all, may work for some companies, but for most, it just doesn't, right? And that's really where these PaaS solutions kind of have their problems. On one hand, it's amazing. The developer experience with a platform as a service, being able to type CF push, give it the directory, and I get back a URL is amazing. Much better than writing 100 lines of YAML. On the other hand, it doesn't suffice all the needs that we have. And that's where Tanzu Application Platform really comes in. Because what we're also seeing is that 98% of code bases have open source. This is an official number, although I would say it's closer to 100%, because even if you're not bringing in open source directly, those things are bringing in open source. There is yet to be anything that isn't open source that I've found. Microsoft itself, the most proprietary operating system in the world, is based off of open source technologies. So you have open source in your organization. And adoption of Kubernetes is just growing, and the scale is growing, and we need to figure out how to deal with this. And the most important thing really is, how do we do this DevSecOps approach? How do we actually bring security in? And one of the challenges that we saw with most platform as a service is, great, so I got my application, I can give the code to the platform, it'll build it and it'll run it. That's great. But now if I need to do security, so I need to do that before, because the security scanning doesn't happen as part of that pipeline. So I'm building now a Jenkins pipeline around Cloud Foundry. And then I don't get that experience of the CF push. Once we start to deal with security, once we start to deal with adding in all these vulnerability scans, the platform as a service that didn't deal with that, which is every platform as a service till today, kind of had an issue that the great developer experience was wrapped around by a CI/CD pipeline because it didn't actually solve all my needs. So it's great that I could run a single command in my CI/CD pipeline, but the developer's experience wasn't that great anymore. And that's where Tanzu Application Platform comes in. I don't believe in marketing, so I'm going to move on here and talk about kind of this idea of inner loop and outer loop.
Can I stop you for
Yeah.
a question? We have a question coming in from YouTube. Does Tanzu Application Service run on top of Kubernetes or Bosh?
Awesome. So Tanzu Application Service runs on top of Bosh. Tanzu Application Platform, what we're talking about today, runs on Kubernetes. So yes, naming at VMware, very close names, very different products, solving very similar issues, but in very different ways. So yeah, Taz is on Bosh. There was originally a Taz on Kubernetes beta, but that's been superseded by Tanzu Application Platform, and Taz is still growing and happening in the Bosh world as well, though. So yeah. Now, in general, if we look at this, our developers have two different types of working streams that we have, or loops of iteration within the world of development. Number one is our inner loop. How does our developer actually quickly iterate over their application? This is during the development cycle. They basically want ops as far out of that cycle as possible. They don't want any interruptions. They want to iterate as quickly as they can. And on the other hand, we have the outer loop, right? That's how do we actually bring, great, our developer has written code and all of that. How do I actually bring this now into production? How do I actually pass this through my different environments, dev, staging, UAT, QA, whatever it is, up until production? How do I add in security? How do I do all of that? And one of the challenges here is something that I think TAP can solve as well, as we'll see, is how do we make it so that the transition between the inner loop and outer loop is actually as smooth as possible? And how do we make sure that even without impeding on our developer and causing issues in how fast they can iterate, how do we make sure to give them as much feedback as early as possible on issues that they will encounter in the outer loop? Because if we say, great, we're going to do inner loop, we're going to do local development, everything's going to be great, we're not going to add security scanning there, source code scanning, testing, image scanning, any of that, awesome. They're going to put up their image into the outer loop, and they are going to get now blocked on every single thing because they have 1,000 vulnerabilities inside of their image. If we give that information quick enough, they can fix that early enough. Right? And just today I was working by a customer and we saw that they had an image for Thanos that's using Go 116. That's okay. Kubernetes also till very recently was using 116. Well, 116 has a high vulnerability now. Any version of 116 has a high vulnerability right now that's scanned by different image scanners, and we couldn't bring in an image into the environment. So if a developer was to go and write today, he would go and he starts to all of a sudden writing Go 116, and we had the scanning set up. In the inner loop, I want him to know, hey, you should be using 117 because this isn't going to pass in production, before he starts writing things and then start upgrading your Go mods and everything in order to upgrade from 116 to 117.
Yeah, you want to try and catch that stuff early, right?
As early as you possibly can, right? And that's really where the strength, I think, of TAP comes in, is at that point. That's really the first strength. Now, when we talk about deploying an app, the first thing is actually before we deploy our application. It's how do we get our developers started? A lot of times when we talk to companies, you get a new developer, he signs on to the company. What's the first thing he does? Gets an 150-page wiki, read this on how to start scaffolding your application and how to start building out an application, what our standards are for a Java application, what our standards are for Node.js, what our standards are for all these languages. And they actually have to go and learn what the standards are of the organization, how we work, learn everything. And these are things that can be codified, a lot of them. But a lot of things are done in, great, read this white paper, read this document that explains exactly what you need to do, and how we work internally. And that documentation is almost never up to date, because huge amounts of words no one likes to update. But also it just makes it very difficult. I was talking to a customer that said a developer, until he touches the keyboard, it's 3 weeks, because he has to learn our internal processes. And that's difficult. That's usually more in the enterprise companies than in, the startups where, it's kind of the Wild West when we're writing code and, we're just trying to get things running. But, we're seeing that a lot in the industry today. And that's where Application Accelerator comes in. So it's kind of an idea of giving a blueprint or scaffolding to any application, whether it's to be run on TAP or not. It gives us this way to really scaffold out and create these templates and blueprints that we can expose via service catalog to our end users, where we'll say, hey, I need to create a new Spring Boot application, or I need to create a new Node.js web app. Well, we have standards in the organization of what the folder structure should be. Which specific libraries do we automatically want inside? Let's say Spring Boot actuators. We want to actually add that in to all of our Spring Boot applications, or we have a specific Node.js dependency that we want imported, right? We have all these different things, and we can actually add those in to our platform to really, accelerate our developer. And the great thing here, we'll see this throughout the entire thing, is that everything is based off of Git. So accelerators are actually defined in Git repositories. And the goal is to take the code that you generate, write it, and push it up to Git, and use Git as the source of truth. Everything around TAP surrounds Git, because GitOps is the approach that is the best in the Kubernetes world.
This is awesome, Scott. If I could just ask my own question. Who would you see as the kind of the person to set up those accelerators? Who is going to be creating the platform here?
Yeah, so I think that, it really depends on the organization. If your organization has, SREs and things like that, they're typically going to be the ones doing this. The architect team that are, anyways, the ones that were writing those white papers on, writing the documentation on how an application needs to be written, they're the ones that are just going to codify it, because there's no code in it. That's the beauty. You don't need to write code to codify an accelerator. It's just YAML. So you don't need to be an experienced developer in order to do this. And the way that I see it is really that, out of the box, we get some good, sample accelerators from VMware. And then what I think will happen is that the SRE team, the architects within the organization will start to build out these accelerators, and then developers will come with their feedback. Developers will say, hey, actually, this and this and this. And, there's a lot of communication. And I think the way it'll work is that, the SREs will have the final say. The developer can say, hey, I want this, this, and this to get started. And the SRE will build that out, and he'll have the permissions to create this new accelerator and then expose it to the developer.
I think as a platform engineer, you're kind of always crossing context and trying to integrate a bunch of systems together, right? And you're looking for anything that can get you the most amount of quality glue work possible while still maintaining the developer experience, keeping that high feedback inner loop. But then it's like your developers, they have all of these needs, oh, what if I want to add some integration testing in? How can I get, this JUnit XML file to spit out to this system where these people want metrics? Or can I do blue-green deployments with Flagger or, Argo rollouts or something? The SRE team is like, okay, well, what is the tool that I can use to glue this stuff together? And how do we get oversight and how do we manage it? Is this something that we want to make exposed to other people, right? Thanks for talking on the persona a little bit, because I find that if you have something that's like a leaky abstraction, it can get really annoying as a platform engineer, right? So it's good to hear that this is meant to be extensible.
Exactly. It's completely meant to be extensible. We'll see that, just in the demo in a few minutes. We'll actually see some of the accelerators that I built. I actually built one, I'm almost done with it right now, that actually creates a TKG cluster configuration from a UI. It's about 150 different parameters. That's why it's taking some time to write it. But basically, it's just using some YTT in the background and some more of the Carvel tool set to make this all work. But yeah, and you can really make this as extensible as you want. And that's what's fun. And this is what it looks like, right? So you get this kind of UI, and a developer would see this catalog. They could choose what they wanted to create. And then they're given this form where they get inputs. And these are what the SRE or whoever wrote the accelerator exposed as options for them to fill out. You could have drop-down lists, Booleans, and numbers, strings, whatever you want here is types of fields. That the great thing is once I've filled anything out here, this actually ends up being overlaid into my files. So if I said my application name, and that needs to be changed now in the title of the web page for the demo web app, and needs to be changed in the Kubernetes manifest, and needs to be changed in the tilt file, and changed in this file, and changed in this file, we can do text replacements, we can do including or excluding of files, we can do rewrites of paths, we can use YTT to do some more advanced changes. And we can really go and actually scaffold out that application. So all these inputs can be used to actually take that kind of scaffold application, that template, and customize it for the end user. And then all they do is click download zip file, and they got a zip with their updated code based off their inputs and can get started developing. And it's a really nice way of getting started. And what this actually looks like from an SRE team, what they actually have to do. So they have their code, whatever, their source code example, and they create a file that starts like this, accelerator, they give it a display name, they give it a description, an icon URL, and give it tags so that it's searchable through the UI. And then they give options. What are the inputs that I would like? You can have what type it is, you can have default values, you can set descriptions, you can set if something is required or not. You could have conditional values. So this depends on if the user selected dev mode, then show this value, right? So you can actually make a really customizable form.
Hey,
and then
have a question.
That's it. Yeah.
We have a question from Java Grunt. Can we make the accelerator create a GitHub repository and pipelines instead of exporting a zip?
So no, the idea is it generates the zip, and then you can go and push that up into GitHub. There's a few reasons for this. I think that one of the reasons is that, when we're doing local iteration, we don't necessarily want it to be in Git yet. We want to do our first iterations on the application, get it running in our local environment, and then push it up to Git. I think the other real reason for this is that we're using Backstage as the UI here. And Backstage is currently mostly a read-only system. It's not really meant for write access and things like that, just in terms of how it's built at the moment. So having it pushed to GitHub would be a bit more problematic in terms of just how access control is configured there. But I think it would be an interesting thing to see if it can get there down the road. It's just not doing that at this moment. And so really, App Accelerator is great. We'll see a demo of it in a minute, but then we need to meet our developers where they like to live, and that's in VS Code. VS Code or any IDE in that case. But we have an integration into VS Code. So what this enables us is to actually take that next step. Once I've downloaded my Accelerator, what do I do now with that code? How do I start to iterate quickly? And one of the things that, is I think the most amazing about Tap, and I'm actually going to click ahead to the final slide here for a second, is this page, and talk about this for 1 second. This is a slide that I built of the open source technologies used in Tanzu Application Platform. Things here are with thousands of stars on GitHub, are all very commonly used tools. Tilt for local development. Anyone that's developed with Kubernetes, as developed on Kubernetes, has probably used Tilt. VS Code, industry standard. Knative, Kpack, Contour, Backstage, Tecton, Cert Manager, Gripe, FluxCD, Carvel. All of these different tools are used here, and Tanzu Application Platform is built 100% on these open source technologies. And that's where the strength comes in. So the VS Code integration, VMware didn't come and just build everything from scratch. There's already an amazing tool that can help us with local development called Tilt. Let's integrate with Tilt. Great. We need a UI. Great. Let's integrate with Backstage and customize it for our needs and add our own commercial edge to it and add more functionality. But let's use these industry standards. And the reason this is so important is that when we would go in with any other platform as a service in the past, it would be, so all the knowledge I have in the organization doesn't matter anymore, and I need to hire an entire new staff that understand this proprietary technology that if we decide to change platform as a services down the road will be completely irrelevant and I'll need to retrain them 100% again. The answer here is no, because we're using industry standards. The knowledge on these tools exist. Knative is one of the most common ways of deploying on Kubernetes today. Contour as well. We have all of these tools that just people are used to, so it's very easy to integrate into the system. And I think that's really a strength point as well. And so back to what this actual VS Code integration gives us is that, it gives us this ability to integrate with Tilt to give us local development. So we can rapidly iterate over our applications. Basically, we have this idea of live update, which is for anyone that's used Tilt, is aware of this idea that you can basically connect a remote environment to your IDE through Tilt, the Kubernetes cluster. And then when you make changes in your IDE, automatically that code is reloaded into your application running on that remote cluster. So I can be writing my Java code and it's updating live within Kubernetes as I'm writing it within my IDE. And that's really an amazing capability. The fact that I can get the security and everything of that remote cluster and at the same point, do it all from the comfort of my IDE without needing to redeploy every single time. So let's actually go into a demo here because I'm sick of slides and I can't deal with them anymore. So let's move to an actual demonstration here. Now, one of the most amazing tools within Tanzu Application Platform is this tool called Learning Center, formerly known as Educates. And what I've actually done here is built out a workshop for Tanzu Application Platform using Educates, using the Learning Center. So what we'll actually do here is this is one that I built for just how to use TAP. So let's take a look at what this actually looks like from a developer's perspective. So this is our Tanzu Application Platform UI, and the application accelerators start here. So this is where we have all of our different accelerators that we've built out. Most of these are coming directly from VMware here, and we have this demo web app that I've built. So if we clicked on the view repository, it'll bring us to the GitHub repo where this is all located. Everything in this session is all under vrabbi in GitHub. But here we have our demo application accelerator. And we can see here all the different options that I've set. And then we have this section here called Engine, in which I'm actually just telling the accelerator what to do with these inputs. So while we can do it from the UI, which is nice, we can also do this using the CLI. So that's what I'm going to do here. I'm going to run Tanzu Accelerator Generate, give it the name of the accelerator, tell it where my accelerator is located, and then give it these different options, the fields that were that I had requested as a developer to
Could you
supply
zoom
me.
in a little bit on the very
Oh,
thing?
yeah, for sure. How is that?
Definitely easier to read. I mean, it goes off the side, but you can actually see
hold
what
on.
text is. Yeah, I think
Yeah.
that's good.
Awesome.
And we have someone as well, the Flessie Sysop, just commenting that app accelerators and Learning Center make it so much easier for devs to get onboarded in TAP. So
Yeah, no, it's been
compared to Cloud Foundry, I guess is the context.
Yeah. It's definitely, amazing to have a tool for learning built within a platform that we can actually expose then to our customers to how do you get started, right? It's pretty amazing. I completely agree with that. So let's actually see what happens. I just unzipped my, zip file that I downloaded. And one of the great things about Learning Center is I get VS Code directly in my browser. So here we go. I've got VS Code using Code Server. I guess I should update this demo to use a new version of Code Server. But so here we go, and this is my application. This is the accelerator that I just created. So if I were to look here, this is a standard Java application. We have our hello controller that's saying greetings from Spring Boot plus Tanzu. Awesome. Beyond that, our application does absolutely nothing. And if we look at the files that actually exist, so what we also have is this file here. We mentioned tilt. So this is the tilt file. And this is generated for me by the accelerator. This is customized. So we can see here, this has my Harbor FQDN in here where the image is supposed to be saved. I have here the name of my application that it's going to be creating. We have everything already customized for us here, which is really awesome. So once I have this built out, I'm ready to start iterating. So what do we do? Well, I have a tilt file. I right click on that and click on Tanzu Live Update Start. This is how a developer would actually start working with the platform. So they've downloaded the accelerator and now they're running a live update start. And this is going to take just a few minutes. Now, what we'll see in a moment is what's actually happening in the back end with a live update start. First thing that's happening right now is let's go back to our terminal and do a kubectl get pods. And the first thing we see that's running is a test pod. So this is using Tecton in our case, but this can be done with Argo workflows, with Jenkins, with whatever we would like. This is running tests against my application. This is running, in our case, a Maven test. And it's simply bringing up the application, and it ran its tests. It succeeded. There were no failures. And now that this step has passed, we're now moving on to our next step, which if we come here and do a kubectl get pods again, great. We now have source code scanning. So this is running a scan using the Gripe open source scanning tool. This is also completely pluggable, so you could change it for SNCC or whatever you would like as a image scan as a source code or image scanner. And that finished. If vulnerabilities were found that broke the policy that I configured in the cluster, the supply chain would stop here, right? Our path to production, our deployment cycle would actually stop. But because we didn't have vulnerabilities, we're good. So now we're using Tanzu build service, and this is actually going and building my application. So if I do a get pods, we can see I've got my build pod happening that's running using the open source Kpack wrapped together in Tanzu build service, and which is part of TAP. This is taking my source code and actually building a container image, pushing it to my registry and signing it with a cosign key so that this image is verified that it was created through the platform. So this is running, it finished building, and we can see here that all of our logs are streamed to us in VS Code, so they don't need to be doing a kubectl get pods. And everything here, we can see which workload it is, in which container this is running, so we get the full visibility. The developer knows exactly where this is at right now. So now that that finished, we're back to doing scanning. But why are we doing scanning again? So the reason we're doing scanning again is because we're now scanning our image. And just because my source code was fine, that does not mean anything about my actual image. What happened with the image that was built by Tanzu build service? Is it actually secure? What additional vulnerabilities were added in through the JVM or through the JRE or through different libraries, OSs? So we're running the scan there as well. And once that finishes, we're then going and creating our manifests to deploy to Kubernetes automatically. We don't have any Kubernetes manifests here. We only have one single YAML manifest, and that's this one. It's called a workload, where all we've defined here is where my source code is going to be located and which branch that's in. That's all we need to mention here, and we have a label. That's all. And from this, what we're getting is this is automatically generated for us, a Knative service manifest with all different best practices in it. So the platform recognized that this is using Spring Boot. So it configured here different conventions that are best practices around Spring Boot. So it set best practices for the Java tool options. It set all of these different variables. It understands which container port I'm using. It automatically configured which user this is going to be running as. And this has been done. And now we can see my workload log. So this is actually running. Now, one of the things I could do here is a Tanzu apps workload get to Java web app. And we can see I get a URL here. By the way, anyone that wants java-web-app-demo-portal-w01 S023 KSV Rabbi Cloud, that's accessible from the world. So you can access it and you see greetings from Spring Boot plus Tanzu. Yay, our application is live. By the way, it also does work with HTTPS. And it is signed. So we've got our application, but our developers don't want to work that way. So Tilt automatically goes and forwards this to us on localhost. So I could just do curl to localhost port 8080, and I've got my application. So that's awesome. But now let's see the development, right? So they waited 5 minutes to get the application up and running. That's fine. How do they now quickly iterate? So let's go back to the UI here. And we're going to go to our Hello controller. And let's select our greetings from Spring Boot plus Tanzu line. And you know what? Let's change that with greetings from, let's say, Tanzu Tuesday. Awesome.
And
so I've updated my app. Yeah.
There's a question in chat about that Jerome had about could we use the Tilt web UI here instead of the text one?
So yes, there is access to the Tilt web UI as well. You can access it. I don't remember what port that's on, but you can use it. Either way is possible. So it's fully supported though. I just do not remember the port of Tilt, so couldn't tell you right now. But now that we've updated this, right, all I did is made a change in VS Code. Then let's try and access my application again. There you go. It's running with my changed text. And if I come back here and with Scott, and come here and just do a refresh, it loses for 1 second, and there we go. So our application is automatically, we can iterate on it. We can make these changes. We can develop locally. We can use curl to localhost. We can come and access it actually through the Knative service on the web. And this way we get this local development. Now, this is running on an EKS cluster. This isn't running locally on my computer. This isn't running in a kind cluster. This is running, if I go here and run kubectl get nodes, this is running in EKS. So I'm running remotely against a remote cluster, and automatically this is iterating. That is the strength of this platform. Now, unfortunately, in today's world, people came up with this idea that containers mean that it worked on my computer, so it'll work on your computer, and solve the issue of, but it worked on my computer. Well, it doesn't. In the Kubernetes world, we have policies in clusters. We have runtime enforcement using tools like Aqua and Prisma and Carbon Black for containers and all these things. And it is not true anymore that it worked in Docker on my computer and kind on my computer, that it works in my production cluster, because I have OPA policies that don't allow something. Well, in our case, it does, because it's actually running on that cluster. So you could use this on kind, but one of the strengths is we can use a shared development environment and actually go and work against that and make sure from the beginning that everything is secure. The developer started and the scans were run. Anytime he does a Tanzu live update start again, it will run the scans. So he can easily, without pushing a single line of code to Git, he can get all of the code done, which is pretty awesome. Now, if we actually took a look at this just for one more second here and actually looked at our workload YAML, and we can see I'm actually pointing to a Git repo. This is using Git in my case. Well, hold on, but I told the workload where it's coming from, and it's not here. Where is my code? I'm working on a remote cluster. Well, this is where Carvel comes in. So Carvel have a tool called image package that allows us to package up anything we want, basically, into an OCI compliant image and then push that to a registry. So we don't only need to store container images now in a registry. I can store configuration or code or anything as an artifact in a registry. And the way that this works is that when I did a live update start, actually all my code here was bundled up in the background into a bundle that was pushed then into my image registry, into Harbor. That's what I had configured here in this tilt file automatically, that this URL right now, if I go and actually access, I think I actually may have it open, yeah. And if I log in here and go to S023 and look, this is my app code. It is saved up here in a bundle. And by the way, no vulnerabilities, yay. So this is located right here. So we have our code in our registry, and then that gets brought into the environment. So we don't have anything yet in Git. Now, okay, how do we actually get this into Git now? Because that's what I want to do. So let's stop the live update. And you know what? Let's also delete our application, because I don't need my application up and running. Now, I see there's a question here.
A question, yeah.
Yeah, if I have OPA or gatekeep or Kyverno policies in the inner loop cluster, how would policy errors be handled, or how can I enforce policy compliance before it's pushed? So really, because this is being deployed on Kubernetes, you would get those errors from the client from Kubernetes into VS Code. So if the pod being deployed failed to be deployed because a Kyverno policy or an OPA policy denied its admission, the developer would see that in the UI. So just make sure that in your Kyverno policies or OPA policies, you're actually throwing helpful error messages. And if you do, they get that experience right away. Now there's another question here. Does it actually scan the code for vulnerabilities, or does it try to interpret it as a container image and is like, yup, legit, no vulns there? So that really depends on which scanner you're using. If you're using Claire, the answer is no vulnerabilities, it's not a container image. If you're using Trivy, it depends. It knows certain languages how to scan, in other languages it doesn't. That's why we have the actual source code scanning inside of TAP, because we don't trust that, because it's built for images. It has capabilities around source code, but that's not its strength, right? So we're using Gripe for that in the pipeline.
And that's kind of the
I just like
point,
seeing
is that
green in Harbor.
These pipelines are also completely extensible, right? So if you want to, say your security administration wants to use Trivy versus something else, or if you, kind of have all the SNCC tools, and you can plug in exactly what you need to.
Exactly.
You can probably plug in SonarQube there, right? And then
you can
code analysis that way. So there you go.
You can, right? You would do that inside of the pipeline within the supply chain. And it's really easy to do. We'll see that in a second. So now that we've actually done our application there, let's actually see, okay, now I have finished iterating locally. I want to get this out into the outer loop. What do I do? Well, let's push it to Git. So we're going to add our repo. We're going to commit that. We're going to push it up to Git. And if I come back to my Gitty here, yay, our code is in Git. Awesome. So how does someone actually go and deploy this to Kubernetes? Well, they would run Tanzu apps workload create Java web app and give it the file of their workload YAML. So let's actually run that. Yay. And that ran. So what is this doing? We see this is the YAML file that I gave it, and it's saying, awesome, I'm creating that for you. And now, well, that just created, how do I get the logs? How do I know where it's at? How do I know all of that? So we have this Tanzu apps workload tail command. And what this is doing is giving us the same logs that we saw through VS Code of all of our containers, of all the different steps of the supply chain. We can get that through this Tanzu apps workload tail command. So even when we go to deploy to production, through a single command, we can get that same kind of experience. Now, we don't have the live updates here, right? Because we're not using Tilt. But this is for a production deployment. This is deploying into an actual cluster from the outer loop from Git. So this is going to take a few minutes here as this deploys. And in the meantime, what we can actually do here is look at another kind of example here. So what we saw is how this deploys into, takes the code and deploys it within the same cluster. That's very nice. But what we're seeing today more and more is that we need a GitOps approach. I want my pipeline to build my configuration, yay, push that up to Git. Because I want to be able to now push that out or pull that in from multiple clusters using Argo or Flux or Cap Controller or whatever it is. Yay, I like the question about test containers. I just learned about test containers from Cora recently. So the answer is that you can run tests with a DB started or whatever. The way that this basically works, you could actually also use a real database if you wanted, because the way the tests run is that basically it's using Tecton by default, and those tests are completely up to you what you want to do. So if you want to add a Postgres database deployment into Kubernetes, or to use test containers, or whatever it is that you would like within that test, it's completely customizable. VMware give examples in some of the accelerators of like Maven files or Go tests, but you can write whatever testing you would like, and that can be integrated here. As long as you return fail or success, we're happy. So if we go here actually and take a look, so we were mentioning GitOps is one of the things that we need to do, right? We want to work in GitOps. So let's take a look here. And the reason that I like to do this right now, that I'm going to show this now, is that Java has to download the entire universe in order to build an application, and luckily Go is very quick, so it fills in time. So if I look here at my workload YAML, so this is my workload here. You can see I've added a few more labels. I've added some build environments. So for this Go application, I also want it to be built with specific environment variables during the build process. I'm telling it which service account to use, and I'm giving it a URL, this time from GitHub. And you know what? This time, instead of doing a Tanzu apps workload create, we're in Kubernetes. kubectl apply -f workload.yaml. Why not? Yay, it was created. So let's do now kubectl get pods. And what we can actually see here is that number one, here is our Java web app actually finally finished, which is awesome. And kubectl get workload. Let's see here. Okay, and we've got our supply chain GitOps was selected for GoTap, and for Java web app we have this. And if we go back to kubectl get pods, we should see in just a minute the Go web app should start actually its building process. So we'll give this a few more minutes, and then we'll come back to the Go app. Now, one of the really awesome things here, though, is let's actually look at what happened. So my Java web app is up and running now. We can see these were all of our logs. It finished its building, and it's actually deploying my application now. So that was fun. But let's actually see what this created. So one of the things we have is that we're using kpack here in the backend to build our image. So let's run a kp image list, and yay, that's my image URL. Anyone that wants to pull it, it's in a public repo. If you have enough time to copy that SHA, I wish you all the luck in the world. And now what we could actually do is take a look at what this looks like from a UI perspective. So if I opened up the tap GUI, I have here my Java web app. And if I click into that, I can look here at my runtime resources. So I can see all the pods that are a part of this application. I can also click on the URL, and this is going to bring up my application for me. Now, you might be wondering why this is a bit slow right now. Well, the reason is that it actually scaled to 0. Now, that's configurable, but Knative gives us this ability to scale to 0. That if my application isn't used for X amount of time, hey, scale it down to 0. I don't need to waste compute resources. And that's a really strong capability because we get auto scaling out of the box here. So there's our application, and it's up and running. And you know what? Let's actually go and run a hey command. Just let's run 1,000 concurrent requests for 120 seconds against this URL, just to try and play with the system a bit. And let's go into here. And if we do a refresh, what we should see now is, yay, we're getting all of our pods that are starting to come up slowly. So let's go into one of these pods and actually see what type of data we're going to get here. So if I come back, sorry about that, go into one of my pods, what we can see here is another tool called Application Live View that's integrated into the system. And what this allows me to do is get amazing visibility into my application. I could see all the HTTP requests. I can actually go and understand what the headers were, what the body was, the input and the response given by the server. I could go and actually see the memory usage, both heap memory and non-heap memory within my application over time, and I could generate heap dumps, right? This is using the Spring Boot actuators and actually exposing this in a really consumable and easy way. We could even go to our log levels and change live within our running application the log levels of our specific components. So if we had an issue in our application, I could go and change it to trace for a minute or debug for a minute, reproduce the issue, turn it back to info, and collect those logs and start to understand what was going on without needing to redeploy my application multiple times. And this is really where all the strength comes in. We get all of these capabilities of visibility within the UI. I can see my environment variables, and I can even configure environment variables if I wanted to, right? And this is really where things become so strong. So that's great. Let's take another look at what that type of thing looks like. So if I go here into the Yelb UI, this is an application that I deployed, not using Knative, just using a deployment and a pod. So in this case, our replica set here has a single pod in it. Awesome. Well, what else do we get from this UI experience, from this Tanzu Application Platform GUI? So on one end, I get my runtime resources. That's always fun and nice to have. The next thing we have is view source. That will take you to GitHub to exactly where the source code is. And I could go and take a look here and understand. I get a direct connection to my source. The other thing I have is tech docs. I want to see the technical documentation rendered from Markdown automatically in the system. I want to be able to search my documentation. And this is a really strong capability. From the same place, I can get my source, I can get my tech docs, I can see dependencies, which this depends on which components, on Yelp App Server. And I could click to Yelp App Server, and here I could go and see the tech docs of Yelp App Server. And if I wanted to, I could view the source of that, and I could see its dependencies, and I can see its runtime resources. And we really get this full visibility here that's pretty amazing. And we have this idea of a system and a component, and all the things we were looking at before, the UI, the DB, the app, Redis, are all the components that are part of a larger application called Yelp. Well, it also has its own documentation, its own source. The other thing it has is it can automatically build out for us this diagram. And this is what's amazing. All of our components can automatically, basically, because of the simple metadata that we give, we get this diagram of what our system looks like, what this actually is built of, and how this actually looks. And that's really a very strong capability. Now, that's awesome. We've got this all running. So let's actually go and see what else we get out of the system, because it doesn't end here. So I want to do GitOps iteration. So I've deployed my app, Tanzu Apps Workload Create. Awesome. I want to make a change now. So let's go back into our UI here. And what we're going to do is go to the Hello controller. Yay. And I'm going to make a change here. Version 2.0. Yay. As you can see, I'm a really big Java developer. So I'm making really serious code changes. Yeah, I don't know Java well. So I've made my change here. Awesome. And let's push that to Git. Awesome. That was pushed. So now, kubectl get pods. And what we will actually start to see is Tanzu Apps Workload get Java Web App. And what we'll see in just a moment is that we're going to get a second test pod. And that second pod that's going to come up is basically, it automatically recognizes that a change happened in my Git repository that it's watching. And it will go and trigger the entire supply chain again for me. So this is going to come and run another test pod. There we go. We can see here our new test pod that's running. And that test is going to finish, and it's going to run a scan. And that scan is going to pass. It's then going to go and do a build. And then it's going to do a config writer. And then it's going to create a new revision of my application and actually weight shift and transfer over the traffic slowly from revision 00001 to 00002. And that's really where this strength comes in. Everything is done here in a really smart and iterative way. So we can see now build pod 2 is in the pending state. If I did a kubectl get pods, we can see that it's starting to initialize right now, the new build. It's already finished scanning. And when this finishes building, which we'll see is going to be very quick, what's going to happen then is it's just going to do the scan and push up and deploy automatically for me. This is how to do things in the right way, quickly, easily, and securely. Now, how does all this work in the actual backend? If we were to look at this, let's actually take a look at one more thing in terms of security, and then we're going to get into how this actually works, because that's the fun part. So what I'm going to do is actually skip over this one just because of time. And we're going to use the vulnerability scanning, because this is the fun part. How do I actually check like the vulnerabilities in my images, and how do I deal with DevSecOps? So all I'm doing right now is exporting a few values so that I can actually access the metadata store. So what is the metadata store? Within Tanzu Application Platform, we have this metadata store that is backed by a database, and any scan that happens throughout the process, whether that be a source code scan or image scan, the data is saved into this metadata store. And what this allows us to do, it basically tracks all of the data. And then we can very simply query this metadata store in order to get the information that we need. So let's look, for example, at what that means. So here I'm simply exporting the image SHA from the image that was created, the latest image of Java web app. I just exported the SHA of it using kubectl. And let's run an image insight image vulnerabilities. Let's see the actual command here. If I just do it in a comment, image insight vulnerability -d for digest, and gave it the image SHA. And what we get here is in which packages, which vulnerability, at which level is this located in. We get all of this data straight out of the UI. Now, that's cool. I can also get that vulnerability data in things like Harbor with the Trivi scanner or in different image registries. But one of the other really amazing things is this other command, and there's a bunch of commands here. But the next command is, let's say that I came as an organization and a new CVE comes out. The CVE, let's say for log4j, yay log4j, and that comes out, and I need to see which of my images are vulnerable. Well, insight vuln images -c, give it the CVE. And what this will actually do, if I run this, we'll see, okay, so for this CVE, this image with this SHA in this registry has it in this package. And this image with this SHA has it in this image. And the same thing here, and here, and here, and here. And all of these images of mine that are managed by the platform have this vulnerability. So this becomes a really easy way to start querying our data and actually gain real benefit from this data. That there's a CVE that we're worried about now, great, let's find where we have that. If you could figure out where a specific vulnerability was in all of your images, makes it much easier to go and fix that. So this is a really, really strong capability. Now, one of the biggest questions always is, okay, but how much YAML actually was there in this whole process? How difficult would it be for me to actually run this? So let's put that to the test. And the way I'm going to do that is a very simple script here that we can look at. And I'm using a plugin called kubectl lineage that basically tracks all of the owner references within Kubernetes and pulls out from a top level resource that you give it all of the sub resources that are owned by that. So for example, the workload created the Tecton task that ran to do my tests and created the kpack image CRD to create my image and created a Git repository CRD for Flux and created all these different things in the Knative service and all of these different objects. So what am I doing here? I'm saying, great, give me all of those things, split it out, whatever, doing some grunt magic here. And then for each of those, we're basically just saving it out into a file. We're getting that object and we're running kubectl exporter, which is another plugin that allows it basically just to strip out all of the metadata and things that don't actually matter. So we've exported all of that into files. That's cool. The other thing that we can do now is run the same thing here for kubectl. Let's see which command it was here. Let's do the same thing for our Knative service because that isn't owned by the workload. So what we're going to do is run one more command here. And this is just going to basically get our Knative service of Java web app. And it's also going to export this into files. And then all we're going to do is actually just run here a exporter on our workload here. Excuse me. And we're just going to echo out what the length is of all of these different objects, because that's what matters. I want to know how many lines of code were here and how many there. Well, there you go. My workload is 11 lines of code, and that's the amount of generated YAML length. Now, that is from 3 iterations on my application, right? A lot of that YAML is the same, but you have Git repositories, you have source scanning, you have image scanning, you have all of the different things. You have pod intents, the things that we're adding in the best practices for Java. You have all of these additions that are happening in the back end, and all of that, the iterations, any changes, the changes that I need to make here is insane. Between every single version, the amount of changes that I need to make. And here, all of that happens out of the box for me. I don't need to worry about it. Great. It created all of my YAML for me. I don't care. I gave it 11 lines. This is what it produces. And that is what's so amazing here. How much was created for us just out of the box like that? Now, one of the things that we had looked at was that idea that if I go back to my workload, actually, I have this label here. And this label actually really matters. And the reason that it matters is that this workload is actually managed by something called a supply chain. And if we take a look at what that actually means, and I go and open up my terminal for a second. By the way, anyone that wants, put in the comments here, where would you prefer to see the next part, in Tanzu Community Edition, TKG, or EKS? Because I have it running on all 3. So if there are any preferences, let me know. Anyways, if we go and take a look here, let's actually just open up a new session for TAP. And if I go here and take a look at what's actually happening behind the scenes, you know what? Let's do it from TC, because that's more fun. I decided. There was no answer, just a tough question, so I'm going to use Tanzu Community Edition. Yay. So if we come here, and I go to CD to tap. And actually, let's do a kubectl get cluster supply chain. So what is a cluster supply chain? We can see here that I have 3 of them. One called source test scan to URL, another one called source test to URL, and another one source to URL. These are out-of-the-box supply chains that come from VMware. So let's take a look at the simple one, and then we'll progress. So I'm going to do a kubectl get cluster supply chain source to URL -o YAML. You know what? Let's do a kubectl exporter into and let's just open that up. So let's look at our supply chain. So if we take a look here at what a supply chain looks like. So it has a name under metadata, awesome. Then we have our spec. And basically this is a graph, this is a list of the different steps that take part of my supply chain. So everything here is a template inside. So we have a source provider, and then we have a deliverable, and then we have an image builder, and then we also have a scanning mechanism, and we have a config provider, and we have the application configuration, we have the config writer, and then we have the config writer template, and we have all these different steps that have happened along the way that are the containers that we saw. Now, we can go into any of these different things as well, but what really matters is you see here that I have my selectors. So what is a selector? My workload never said, hi, use the source to URL supply chain. What did I do? I used the Kubernetes method. I set labels. That label was apps tanzu vmware.com/workload type web. Well, here I have that, but I also have these other 2 labels. So what else do I have? If I went and looked at my other cluster supply chains, let's say I were to look at source test scan to URL and did a get to that and just did a -o YAML. We're not going to save this to a file for now. And I look here, well, here we have this in true and true. And we have another one that's just web. And we have all of these. And the way that it works is that it goes off of the best match. So if I have on one just workload type equals web, it will select that. If I have two labels on my workload, it will try and find the best match for that. So this is an easy way of having multiple supply chains in my cluster and then letting the developer through labels, simple labels, they can go and configure, great, what actually do I need to do? What exists here? What doesn't exist? And which supply chain am I actually targeting? So all of these different steps here are really interesting, actually. And if I looked, for example, at the source provider, so it's a template reference to a cluster source template called source template. So they get cluster source template, source template -o YAML. Well, let's see. We can see here the beauty and how everything works. I love YTT. For those that didn't see the TCE session, well, you can. There was a lot of YTT there, and there's about to be a lot of YTT as well on the screen, because that is really the strength here. The customization capabilities here are endless. Because we have this idea of a cluster source template, we're not tying it into what we can see here within this cluster source template is that we're actually generating a source toolkit fluxcd.io v1 beta 1 Git repository. So this is the fluxcd implementation of a Git repository CRD. That's great. And we've created it here. But if I wanted to change this out for a different implementation, I can. Because the connection to the supply chain is simply through this template that I can template out. I can add YTT. So if my workload has labels, then add them. If it doesn't have, then add this. We can set all these different values and make it conditional. We can really go as wild as we would like here. And if I want to change out Git repository, change it out. No problem. You want to change out KPack for, let's say, Canico to build your images. If you, for some reason, are a fan of Docker files, go right ahead. I've actually done that, and it works for those that like Docker files. And we have all of these capabilities. We can actually see that here. If I was using a Git repository, then we're creating a Git repository from Flux. If has attr spec source.git. Well, what if I'm using live update? We said I'm not using Git as my source. Right? So in that case, what we have here is our image repository coming from sources apps Tanzu vmware.com. And that's really where the strength here comes in. Am I breaking out here? It looks like I'm breaking out.
I didn't have any problem.
Can't tell.
Yeah, you're great.
Yeah, it maybe just for like a moment, but it sounds good now. So
Okay, awesome. So
awesome to see these different CRDs in here. By the way, I'm a huge fan of the Flux project, and of course, using image repositories as well for more of that registry process. Really cool flow.
Yeah, no, it's a lot of fun to really get these, different capabilities, right? It really works in an amazing way, and we get all these flexibilities due to Cartographer being so pluggable, and because Carvel is so pluggable. So it becomes a really strong tool for us, no matter what we would like to do. And just to show that in action, because why not? We mentioned that Tanzu Application Platform is built off of open source. Well, that's actually 100% true. So if I open up here, you can see under my Git repository here, under my GitHub user, I have this repository called tap OSS. And this is the entire open source tool set that exists within Tanzu Application Platform. There's obviously proprietary pieces to Tanzu Application Platform. The VS Code plugin is proprietary. Currently, some of the different convention services within Cartographer are proprietary, but the vast majority is open source. And what I've actually done here is built out using the Carvel toolset and built a package repository and packages that works on TCE. That's where I've tested it. The entire basically TAP stack in the same installation experience using all of these different packages. So we have an installation package. We have Cartographer. We have the dev namespace preparation. We have Flux source controller, KPAC configuration, out-of-the-box supply chains, Tecton, KPAC, Knative, Cert Manager, Contour, service bindings operator. All of these things are automatically available because these are open source tools. So we can wrap them together using Carvel and get these into our clusters. And this is a really easy way to get started with the idea of Tanzu Application Platform anywhere. And then when you're sold, because you will be, that's when you talk to your VMware executives or to Terrasky if you would like, or to anyone that can help you go and actually implement the commercial offering as well. But this is an absolutely key part because it is completely open source. And you can use this freely at your own will. I just recently released version 0.20 yesterday, which has a bunch of new additions to it, and this is constantly being updated. And this package repository, it was a pretty much just like a hack over, a day and a half, and it's a lot of fun. So definitely worth taking a look at, and feel free to leave me issues or pull requests. Pull requests are always welcome. And this is really the open source stack here of TAP, and it's really fun to see how this is working, and seeing TAP really being added into the community, and becoming really a standard throughout the community, which is really awesome to see. Now, just to summarize some of this here, we have other capabilities we didn't get into today. A workload can be very simple. We can also add more things. So we could add service claims using the Kubernetes native service bindings, configurations. We can bind automatically to backend services like RabbitMQ or Postgres if we wanted to. Deploying, we don't even technically need that YAML file. I could just give it a command of Tanzu apps workload create and give it all of my variables in a CLI if I wanted to do it that way. We've got the application live view, which we talked about. We have our TAP GUI, which is great, right? All of this stuff is a lot of fun. And what's amazing is that all this comes together. Now, what really matters here is this one slide. And this is what I want to really leave people with, because I think this is critical. We mentioned that Cartographer, or the supply chain choreographer for Tanzu in the official name, has all these different types of templates, that a supply chain is built out of these templates. The reason this is so critical and that this is such a game changer is because these different templates have different owners within an organization. There are the people that are in charge of, everything that has to do with Git. We have things that are in charge of how we push our images, maybe the security team. We have our configuration templates, which may be the SREs saying what the best practices are for how to deploy onto Kubernetes. We have our deployment templates that actually do the deployment itself, maybe are doing GitOps there. And because each of these are unique and different CRDs, what we can actually do is manage them separately as well. We can give RBAC to different teams to manage different resources. And because they are just referenced within my supply chain, I can very easily have someone go and change the proposed what that configuration generator is going to be. They will update that. That's fine. And that's really where the strength comes in. Now, one of the things that we can see, Thank you, Cora. That is, I'm glad to hear that resonates. And one of the things that you can see in, the Tap OSS repo that I built is that I really wanted to show that Cartographer really is pluggable. So, for example, you'll see one there that doesn't use Knative, that just deploys a deployment service and an ingress. We have another one that deploys using Canico. It builds the images and doesn't do it using things like what's it called again, KPack. We have different things that are in the working right now that I'm working on for integrations with Argo workflows and Jenkins as well. And really, that's, I think, where the strength comes in. That just like I had mentioned around, Tanzu Community Edition in the last session, where the real strength is the fact that we're building a community and things can be shared. It's the same thing in Cartographer with these supply chains. And it's going to be really interesting to see where people take this. And I think that's really where the fun is. So yeah, I hope that was interesting.
It's just an electric presentation, honestly. Just constant quality content, constant real perspectives from a practitioner in the world. It's I'm just so impressed with the quality of the platform that you can get by just installing a repository of packages to a TCE cluster, and then you've got live reload in a remote development environment. You have image scanning going. You've got the ability to search for CVEs across your platform. The experience with debugging is amazing with the Spring actuators. It's just really, really cool to see all of these things come together. Yeah, lots of love coming for you in the chat. Excellent presentation. Thanks, Scott. I mean, and on top of that, you've gone up above and beyond, and you've published this as an open source repository that people can go and clone. I mean, I'm a sucker for a live demo that, is something that can be related with and replicated. Super, super cool.
Yeah, no, it's a lot of fun. And I think that, really where Tap is going to go is going to be very interesting because of its pluggability. And because it's completely based off of open source, it's going to be really fun to see, how this actually evolves in the community.
Yeah,
and I couldn't agree more on the ease of installation. The ease of installation is anyone that has installed Cloud Foundry knows exactly why this is such a game changer. Installing Cloud Foundry is not fun.
Yeah, much love for any platform engineer out there, right? It's like somebody's trying to do the DevOps initiative at their company, and they've got 7 application teams. They're like, how do I get this all replicated out on our 7 Kubernetes clusters? And how can I?
And the installation here is a single YAML. The installation is a single values YAML and about 20 minutes to install.
Yeah, I saw that you actually commented with the Tap OSS repo on I think it's the RFC and the Community Edition repo to have a app platform meta package, right?
Exactly.
If anyone out in the community is interested, it's the Community Edition repo issue 2848. Scott just chimed in there saying, "Hey, this is all looking great. I actually have this open source repo that could be a good package base." So. Go there if you want to check it out.
I like, Scott, the empathy that you have for different personas, and then also about the product. I like the clear separation of concerns that you kind of brought up, like within the different templates for the supply chain, but also having the developer only have to be concerned with that workload object, and then the rest of the supply chain is defined by the people who
but then also a developer not being strapped down or prevented from communicating with their DevOps lead or their platform engineer, right? Or prevented from looking into the Git repositories and definitions that make up the supply chain logic, right? Like if they need to have things changed, if once they have a concern or a need for a feature that's outside of what the platform's giving them, they can break that glass, or they can go talk to somebody who can, right? Exactly. But then exactly like what Whitney is saying, it's ultimately we're trying to use software to change the way that our businesses, our organizations, our nonprofits, deliver services to people that, on the problems that matter. And like a developer's job is to worry about that, not about running a service mesh or, configuring image scanning, right?
Exactly. All that should happen in the back end. And what's so amazing here, though, is that while it happens in the back end, you actually have access to all of it. You don't need that access. You can just run the Tanzu apps workload get, but you can see all the resources. It is in Kubernetes. It's not a hidden closed box. You have no clue what's going on. You get full visibility, and you can change that supply chain. I've had customers that have come and said, hey, we use SNCC for image scanning. For a source code scanning pool, not an issue. We can integrate with that. We use Jenkins. Great. Let's do Jenkins instead of Tecton. No issues. That's the strength here. Everything is pluggable. And it can be as closed or as open as you would like it to be.
Do you think that you're going to try turning in your GitHub page there, or like the stuff there, into like a TCE package or anything like that?
I am more than happy to donate it to wherever would like to receive a donation of a repository. Always happy to do that with any of my repos. I think that in the TC community, they're still trying to figure out exactly how maintenance of packages from community members is going to happen. But yeah, always happy to contribute this stuff to the community. That's why I'm doing almost all the development of these things out in the open as well, because I want it out there. I want people to be able to play with it and to test it and to utilize it and learn from it. So being in Community Edition would give it more traction. Awesome. However we can help the community and get these things out there is the better.
I love all the love you're getting in chat.
Yeah.
Yeah, so much love for your presentation. Everyone's always grateful that you're bringing that wisdom to the channel. And again, just RFC 2848 on the Community Edition repo is where any conversation about this meta package kind of being a real thing, and all those maintenance comments and stuff that could go there. So get involved with the community. It's cool. Kind of in the Tanzu Community Edition side of this, instead of just only talking about application platform, is that these are VMware governed projects, right? We've got VMware maintenance, but ultimately the meetings are open for anyone to join. Add features. We welcome outside contributions. It's just a great way to run a project, and it's the upstream for all of the paid stuff too. So just like Scott was saying, if you're using the open source stuff and then find that you want that production license or a little bit of extra support from the solutions engineering team, that's all a path that's there. Pretty cool.
Yeah.
So we have a question: how to provide dynamic config from config maps to application when deploying through TAP?
Yeah, so that's actually pretty easy to do. It depends on exactly what the use case is, but because the actual configuration manifests of how things come out are 100% up to us and are configured through cluster config templates, we can manage that however we would like to. If those config maps already exist within the cluster, we can simply give the config map name that may have some naming convention and map that in. We could do things using webhooks to add that in, like mutating webhooks. If it's a service credential, so something like RabbitMQ or Postgres or configurations like that, we can use the service bindings integration. So it's really easy to add these things in. It just depends on exactly what the use case is, and then, pretty easy to do. If you have more questions on this, feel free to reach out to me on the Kubernetes Slack. vrabbi is my handle there, and more than happy to discuss it with you and even help you build out a supply chain for something like that if you'd like.
That actually gives me an interesting question, because when I was mainly a practitioner deploying services in Kubernetes clusters, I would just use the raw objects, right? And if you want to actually do live reloads on configs. It's sort of the default behavior in Kubernetes, but most people don't do that, right? Like most people, when they want to change their config, they want to restart their app because they don't have live config. And so that's kind of the Knative default opinion, is when you change your configs in Knative, right, it restarts your service. Are there knobs like in the Knative based workloads and application accelerators that allow you to turn on like live configuration, or is that something that's kind of more custom, Scott?
So everything within Knative can basically be tuned through annotations on the Knative service. And all of that you could configure within the cluster configuration template. So that can all be exposed via like parameters on the workload if you wanted, or via annotations or labels on the workload, and you could utilize that. The out-of-the-box supply chains don't include those types of additions, but you could easily add that yourself.
I see. So the SRE team or the platform team could come in here and then add a Boolean value to the workload that says, hey, live config should be enabled in the main config map or on an extra config map. Cool.
Exactly.
Awesome.
Or like scale to 0. Do you want scale to 0 or not, right? By default, we have scale to 0. You could set a Boolean to say disable, and then you would add the Knative annotation on the Knative service saying, hey, don't scale to 0.
So you can enable those opt-ins, and provide developers exactly the sort of control that they want over the operational part of their service. Right?
Exactly.
Great question from Alexander Smirnov there. Thanks so much. Also, Mike Johnson coming in from YouTube just saying, hey, just discovered Tanzu. Thank you for your work. Hope I can figure out how to get all this going in my vCenter. So yeah, lots of vCenters still in the world, right? Not all of us are in EKS or a GKE cluster. So yeah.
Exactly. Get it running. I have this running on an Intel NUC as well. So you can get it running on anything, really.
Yeah, and check out Tanzu Community Edition for an easy UI way to install stuff in your vCenter. So.
Also, your next episode is going to be this one link here, which is coming up on the 22nd. So people are getting like a lot of like, it's a lot of people here. It's like, oh, you have to wait like several months, or we don't know. For you, it's like, hey, in like 2 weeks or 3 weeks.
See you in 2 weeks. And then I'll be here like 2 weeks after that again with Robert and Miles Gray, and yeah.
Oh, nice! I'm here for it. I'll be actually a little bit sad when we don't have you just on the calendar, when I don't know when you're coming next.
This has been awesome.
Yeah. Just a legendary presentation and ops and hacking skills. Thanks so much for joining the stream, Scott. You got anything else to say to our viewers? Got plenty of people still online. So
just, this has been awesome, and really, I would love to see, the repo that I've been building for the open source tap is really based off of things that I've heard from customers and things that they would want. Even if, you just have suggestions of what types of supply chains you would like to see. By the way, all the supply chains and workloads there work in tap as well. They don't just work on the open source. They're completely interchangeable. So if there are things you would like to see, how you would build a example supply chain for something, or what types of workloads and things like that, please open up issues on the GitHub repo, or send me Slack messages on the Kubernetes or VMware Slack. And, we'll add that into the roadmap there, because I really want to make it as accessible to the community as, and I want to test the, length and the width of the flexibility of these tools. That's what I like to do. So feel free to challenge me with open source tools only. I won't integrate with non-open source tools just because it is an open source project. But any other ideas that are open source, happy to integrate into there and give you credit for the ideas on it in the YAML files.
Super cool. All right. Well, thanks everyone for joining the awesome stream that we had going today about application platform. Carvel packaging coming up in 2 weeks. What are we doing next week here on the stream?
We have the Tanzu Vanguards.
Oh, it's the Vanguards coming in. Yeah. That'll be cool too. Make sure to be here next week, same time, same place. So, yeah. All right, friends. Well, that concludes our stream, and we will cue the music. Right. Cool.